Continuing on, looking at simplifying radicals, we're going to look at these next examples down here. But before we do that, I have some good news. And the good news is this statement in here, that from now on, we're no longer going to have to use those absolute value symbols when we take the even root. So when we take a square root or a fourth root, remember when we had variables before, we would put the answer in absolute value brackets to make the statement loud and clear that no negative quantities were involved. So now we're going to make the assumption that that isn't even happening. It's not even a suggestion in our heads. So we don't need those absolute value brackets anymore in our answers. This first example here, we have the square root of x to the 6th. And if you remember in a previous section where we looked at fractional exponents, we could write this as x to the 6th and then to the power of 1/2 and simplify that way. But in these examples, I'm going to take a more direct approach, and that is what I refer to up here when we're taking a root and we have a variable that's involved. We're going to look at the exponent of the variable and divide it by the appropriate number, and that appropriate number will be dictated by the root that we're taking. So square root, what we do is we divide by 2. So here we have x to the 6th. So we divide by 2. 6 divided by 2 is 3. So our answer would be x to the 3rd power. Next example, we're looking for the cube root of y to the 21st. Again, we're going to take, since we have the variable here, we look at the exponent 21, and in this example, we're going to divide the 21 by 3 because we're looking at cube root. 21 divided by 3 is 7. So our answer is going to be y to the 7. I don't know that I've mentioned this before in previous videos, so I'm going to say it now. Remember, when we are able to take information out from under the radical, it's not in the radical anymore. So x cubed is just sitting there, no more inside the radical. So when we pull something out of a square root or a cube root, we throw away the radical symbol. It sits there without it. If we need a radical symbol, it's going to be because there's something left over we weren't able to simplify and pull out. Next example, we're looking at the 6th root of z to the 24. So looking at the exponent of z, 24. Now we divide by the 6. 24 divided by 6 is 4, and our answer is z to the 4. These were all very nice because the exponents were easily divided and nicely divided by the root that we were taking. I'm sure some of you are thinking, well, what if you can't do that? I'm glad you had that thought because I'm going to answer that question now, whether you had that thought or not. So looking at this example, first information we have x to the 9, and we're looking at square root here. So we're going to take the 9 and divide by 2, but 9 divided by 2 is 4.5. It doesn't divide evenly. So when you have a situation like that where you can't divide your exponent by the root without getting any kind of remainder, what we're going to do is end up sort of factoring, breaking our variable down into two pieces with two different exponents, one being an exponent that is divisible and the other variable, well, it will be the same variable, but its exponent will be what is kind of, I think of it as left over. So let's take a look at what it is that I'm thinking about here. So x to the 9, I can't divide 9, or I should say we can't divide 9 by 2 evenly. So what we do is we start to go down by 1, 8. Yep, 8 can be divided by 2. So I'm going to write my x to the 8 there. But now I didn't have x to the 8. I had x to the 9. So I have another x there. So here, x to the 8 times x, there's my x to the 9. So factoring, breaking it down into two versions of the variable, with one of them having an exponent that we can divide, in this case by 2. Moving on, y to the 11. Again, 11 divided by 2, it's 5.5, so we can't use the 11. Let's go down by 1, y to the 10. 10 is divisible by 2. So here we have y to the 10. And again, I'm going to need an additional representation of that variable, y, because what we have is y to the 11. So y to the 10 times y to the 1, 10 plus 1 is 11. Last variable is z, and z cubed. 3 divided by 2, again, not clean, so we go down 1 from 3 to 2, and then we have that other z that is left. We could start to take our roots from here, but since we have looked at factoring, I will break this up into two radicals, and in my first radical I'm going to accumulate all the perfect squares. So x to the 8, y to the 10, whoops, that's a very ugly z squared, and then in this back radical I'm going to put what we have left, this x, this y, and this z. Now we can take our roots here. Square root divide by 2, 8 divided by 2 is 4, so we have x to the 4. Y 10, 10 divided by 2 is 5, so we have y to the 5th. And then z squared, 2 divided by 2 is 1, so we just have z to the 1, or z. And then this information in this radical just sits because we are not able to simplify this anymore.